This is a pretty simple question. If you know remember the formula for angular momentum in an orbit. We need to find the angular momentum of an electron in a given orbit is given to be equal to j. We need to find out its kinetic energy and the quantum number of the orbit. So let us do the first part now. We know that the angular momentum in an orbit is equal to mvr, that is equal to j. Therefore, we know that j is equal to v is equal to j upon m into r. We know that kinetic energy is equal to half m v square. Therefore, we can write this to be equal to half m into j square upon m square r square. So this is equal to j square upon 2m r square. So this is our final answer for the kinetic energy of the electron in the orbit. We also need to find out the quantum number of the orbit. For this we have another formula. mvr is equal to nh upon 2 pi. By Bohr's quantization of angular momentum, we know that mvr is equal to nh upon 2 pi. Therefore, we can write nh upon 2 pi is equal to j. Therefore, the quantum number of the orbit comes out to be equal to 2 pi j upon h. That is equal to, we can leave the answer over here. The final answer for the quantum number of the orbit comes out to be equal to 2 pi j upon h, and the kinetic energy of the electron comes out to be equal to j square upon 2m into r square, where r is the radius of the orbit. So in this question you should have just remembered the two formulae for the angular momentum of the electron in an orbit, that is equal to mvr is equal to nh upon 2 pi.